Hello, Kirtana, I'm audible.
Yes, sir.
Okay, now which topic we covered in the last class?
Transient period.
Yeah, which topic, Kirtana?
Transient periods.
Transient period. Okay. Any doubt in the transient period? Because that transient period which we had a discussion in the last class, that is one of the main important topics. Okay. Yeah, Kirtana, any kind of doubt you have?
No.
Okay. I think Kirtana, in the last class we discussed about charging also, discharging also, right?
Yes, sir.
Okay. Okay. So yeah, let's come up with a problem, Kirtana. Again, the same way. We have already done with the topic. So yeah, I will come up with some problem, then we'll move to the next. So wait, I think it's let me get this. So Krishna, this is the problem. You can try. Okay. Here this is given as time. So this is basically given time in the between. Find the time constant for this given circuit, and yeah, figure of the condition is already given to you. Okay. So this is the condition. Yeah, one more thing which is not mentioned. The moment, like initially it is unclosed. The moment it is closed, so after that condition you have to figure out. So if you're clear with the problem, please let me know.
Yes.
Let's clear.
Sir, is it RC?
How much hit you are getting, Kirtana? Kirtana, how much you are getting? Hello, Kirtana, are you there? I'm saying how much answer you are getting for this one? Kirtana, am I audible? Please let me know first.
RC.
No, Kirtana, it's not also. Please do it once again. Try once again.
Sir, can you explain it?
Yeah. All right. So, Kirtana, look. What's the problem is saying? The problem is saying you have to get the concept, right? If you anyhow make the circuit such that you can only see a battery, okay? You can only see this capacitor because you are bothered about this, and you can see some combination of resistor, right? So you can say that whatever the R equivalent is there and whatever the tau is there, so you will say, sir, tau is nothing but C multiply some R equivalent. Can I say this case now? Am I correct?
Yes.
R equivalent times of C. Because why I'm saying, because okay, let's try to convert all these things into a single register. Okay. How I should do this? Any idea?
These two are in series, sir.
Yeah, which two are in the series?
The upper one and the.
Yeah. So you can say that these two are in the series, right? Okay. So you can say this is in the parallel with this two. So what I can simply say that you have R equivalent as first of all two times of R, which is in parallel with a single R. Okay. Understood? This is one thing. Now this whole configuration is in series with this. Is in series with R. Is this clear, Kirtana? And you know how to solve it. For the parallel, just multiply both, divided by sum of them. Yeah. Just add with extra. What you are going to get? Maybe 5R by 3. This is R equal. And what is the answer? Kirtana, tau is equal to R equivalent times of C. 5RC by 3. Is this clear, Kirtana?
Yes, sir.
Another way, Kirtana, if you are still have doubt how you can do this, let's see. Look, Kirtana, you know this is the circuit, right? You know this is the whole circuit, and I wanted to know what is the if I know what is the R equivalent across these two terminals, I can get the whole thing. Right? Can I see people? Let me just remove this thing because at the end of the day, because after some time, it is just opening this circuit, right? It is not able to make the current over from here. So can I say just remove this for a while? If you remove this, what circuit you are going to get? This. Okay. And Kirtana, now it is a very simple circuit where this is R, this is R, this is R given to you. And you have to figure out what is the R equivalent across these two terms. I think you already can do it, right? What is the R net from these two terms? And we know the way how we can do this. I don't know what is the voltage every point. So I can say this is 0, this is X. If I know this is 0, this is X, I can simply use my method. What is that method I'm talking about? I can either use KCL, either I can use the KVL. Okay, by using KCL, KVL, I will be using the total circuit. Okay, total potential in the circuit. Is this clear, Kirtana? Because if this is X, from here, this point will be V plus X, right? So here you are going to get V plus X. This is the potential at this particular point. Is this clear, Krishna?
Yes.
If this is zero, you really don't know what is the potential at here, so assume it to be the y. If it is y, no, assume here it should be y. Okay? If it is y, what is the current at this point? It is 2y, 2 volt, okay? Y plus 2. Is this clear, Krishna? Or even it's much better because these two are in the series, right? So why to make it a cross kind of circuit? Okay? Even we can reduce it to another way, remove it because they were in the series, right? So I said I have just a battery over here in this way, and it has another resistance as how much is this resistance? Two times of one. Can I say this now? Now, if you see carefully what I have, it is x. So what is the potential at this point? That is x plus 2, right? Because this is 2 volt. So from here to here, you might have something from here to here. This is 1 volt. Okay? So 1 voltage. Remove it. 1 plus x. This is x. So you can see we can really solve this one, right? Is this clear, Kirtana?
Yes, sir.
Okay. Yeah. Or another way I can say that. Okay, let's not go further. Okay, this is the only thing. Okay. I think if you know this part, you can further solve it. If you get the x and y current over this, you can see it. Okay, this is the net potential I'm getting. Because you know what actually I wanted, Kirtana. I wanted what is the net resistance, right? Can I say this? If I get to know what is the current flowing through this portion, I will get to know what is the, if I know what is the potential across these two terminals, if I know what is the current going in this way, I will get the total, what I can say, resistance, right? Because my resistance is nothing but V by I. If I know what is the voltage across this, if I know what is the current flowing across this, that is the whole thing I want to do. You can do it using KCL and KVL. Okay? Whichever method I have given, that is a very simple way. I hope it is fine. You
Yes.
don't have any doubt, right? Okay. Okay, Kirtan, I think I didn't start with the Thevenin's method, right? Yeah, okay, forget to do this. I have one more method that is called Thevenin's to solve these. Okay, whichever method I have just used, that is Thevenin's method. Okay? So, wait, I'll see if I have some problem. Okay, Kirtan, now look, let's do one thing. I will first teach you Thevenin's theorem first, then I'll move to the next problem. Okay, Kirtan, so let's talk about Thevenin's theorem. Okay, this is actually I was supposed to teach you earlier itself. Equivalent to battery. What we do using this for any terminal across 2 points. Okay, resistance of circuit and replace the circuit by equivalent battery, okay, of EMF and resistance. So what actually I am trying to do is, here now look, we have a circuit, okay, In this circuit, we will be taking any two terminals across which we are supposed to calculate. We will first calculate the open circuit. What I really mean to open circuit? Assume this is the whole condition. This is my resistance, okay? And I am asking you what is the potential difference across these two terminals. So what I will do, I will just remove it. I will assume this terminal to be an open circuit, okay? Then I will calculate the whole thing as an open circuit. Then what I'm going to do is I will simply remove this, the rest of the circuit, okay? I will apply the whatever the potential difference I am going to get for this open circuit. That potential difference I am going to apply over here is EMF, net EMF, and the resistance, whatever the equivalent resistance I am going to get, that I am going to apply as a resistance. This is the resistance, this is the back, and I will connect. And you can see I have shorted the connection, right? Is this clear, Kirtana? I am saying you have a very complex circuit, okay? You have a very complex circuit this side, complex circuit. This is a this is a resistance. I am asking you what is the potential difference. So using Thevenin's method, what you are going to do is you will remove it first and you will say what is the net potential difference across these two terminals in this whole circuit and what is the net resistance. Okay. After calculating this, what you will do, you will just put that as EMF and this resistance. Okay. And you will apply the value of resistance. Now you can do whatever you want across these two terminals. Okay. You have got the thing. This is what we are supposed to do. Is this clear, Kirtana?
Yes.
It is quite clear. Okay. So for example, like I'll take an example. Assume this is the circuit. I'm making the circuit. I know Theorem is not a part of NITs syllabus, but still, if you know, it will be better for you. Like you can solve multiple circuits with this circuit. 4 volt, 6 volt. This is 4 volt. Okay. 6 ohms, 3 ohms. Yeah, which is 3 ohms and a 4 ohms. Understood? This is the circuit. Wait, it is 5 actually. Circuit 5. Now, Kirtana, if I ask you what is the current flowing through this 5 ohm circuit? So we have already studied the KCL table, right? We can directly solve using that method also. But right now I wanted to teach you Thevenin, so I won't go with that method. Okay? Two things are there. To find the current through this, if you get to know what is the potential difference across these two terminals, you can easily calculate the current. Can I see this, Kirtana?
Yes, sir.
Right? I know I can do the same by using a simple KCL table, right? But we are going to use a thermal right, for this one. So what I just said, just open the circuit in the previous if you could remember, right? So this is A, this is B. Make it equivalent to the whole of thing. I'll just copy it here. Open it. Open these A and B terminals. If you open this, what you're going to get is okay. So here you have to calculate all the like whatever the potential difference. If you do so, you will be getting the total potential difference across the circuit and the current. Okay. Okay. Yeah, so Kirtana, if in this case, what you can do, because we are really don't know what is the internal resistance of the battery, assume these to be the ideal resistance, ideal battery, okay? Is this clear? Kirtana, is this part clear?
Yes, sir.
Basically, what we are saying is, we are assuming all the batteries in an ideal, okay, because they are not given that they have resistance, so we can assume it to be the ideal. If they are ideal, internal resistance is zero, right? Okay. So what is the net resistance you can see across the circuit? Only these two, right? Which is are in the parallel. So I can say resistance. What is the net resistance is basically 6 parallel to 3. right? Parallel to 3 meaning to say 6 into 3 by 6 plus. How much is this? 2.
two.
Okay. Yeah. So because I wanted to calculate potential, because I need to calculate potential across, because I wanted to calculate current, so I need to get net voltage also, right? So you can
Yes,
say here I have only one loop. I will go in this way. So what is the current? If I say this is the current, what I will say the current is that this is 6 voltage, this is 4 voltage, and here I don't have the because this is open circuit. So the effect of this won't go here, right? Can I say the total voltage? Like what is the total voltage? 6 plus this 4. What it will come as 10, right? So this will come out as what is I? I is basically total voltage 10, 9. This is the current that you have got. This is the current in this circuit. Is this clear, Kirtana?
yes, sir.
Okay. So it means the current in this circuit due to this portion is just how much? 10 by 9. Is this clear? Kirtan, is this part clear?
Yes, sir.
If you apply the KVL, then still you are going to get the same because we are doing this in the loop form, right? I know what is the potential across this. So you know that current across this is this much. So what is the potential difference across these two terminals? Can I say will it be nothing but I into R, or in other way, Kirtana, if I ask you what is the potential across, assume starting from here. You are at right now, you are at the potential VB. You are going in the direction of current, so minus 10 by 9 into 3. You are going oppositely, minus 2 is equals to VA. So what you are going to get is VB minus VA is equals to 4 plus 10 by 3. Is this clear, Kirtana?
Yes, sir.
Okay. So VB minus VA comes out as 12, basically 22 by 3. It means here you can, because VB minus V, mean to say VB is a greater, it means you can apply the bigger battery VB over here and this one. Okay. But wait, I am going to replace the whole thing with this thing, okay, this battery. So what I'm going to do, this is A terminal, this is B terminal. I have replaced the whole thing. It means this is, I'm going to apply other battery this way. B has a higher potential, right? So keep it as this. And in between there's an internal resistance that is R. We have calculated this value. Okay. And this is the 22 by 3. And this is how much I think this would be 2. And this is the 5. Okay. Is this clear, Kitna?
Yes, sir.
Okay, I'll use 5 again. 5 ohms. This is R Thevenin. Okay. And this is your R V Thevenin basically. V Thevenins. You know the value, right? Whatever we have calculated, this is V Thevenins. This is R Thevenins. Is this clear, Kitna? Now you can easily calculate what is the current in this circuit. Is this clear? Any doubt?
No, sir.
No doubt, right? So yeah, this is all about the Thevenins. Okay? This is the concept I used in the last problem. Now if you just go back, you can see we can solve this problem using repeats. Okay? I hope
Yes.
it really makes it won't be difficult for you. If you want, I can solve this problem also in that case. What I am saying, just remove this. If you remove this, you will get what will be the R equivalent, because you just need R equivalent. I don't even need the battery right now. Okay, what is the R equivalent? You will say these two are in the series. Okay, and is in the parallel with this, right? So you will take 2R parallel with R. Whatever the total you are going to get, you will call that as a R Thevenin. So this is the point. This is the term. I really don't want the net resistance. Assume that I am not talking about the voltage. So let's say V Thevenin is something. I didn't calculate it because I don't want. What is R internal? You have got 2R parallel with R. So it is R Thevenin. Okay, what you have replaced this thing with? This R and this C. So here it will be C. Here it will be R. This R. Okay. Now this will become the net R. R Thev plus R. Okay. And if you directly calculate what is the net tau, what is the tau? That's basically R equivalent into C. So this will give you R equivalent. and the C's as it is. Okay. Is this clear, Kirtana?
Yes, sir.
Okay. That then it's fine. If you don't have it down, then it's fine. Okay. I think I can give you another problem now. So Kirtana, I'm just pasting another problem. This one. Try to solve this one. In this, the problem is saying that you have to calculate the charge on the capacitor as a function of time. Okay, as a function of time. Basically, you have to provide an equation for the charge on the capacitor. That's what you would ask us to do. All right, Kirtana, take your time and solve it. Don't take much time.
Sir, is it 72 into 1 minus e to the power minus t by 3?
Kirtana, for the answer for this problem uh, is charge in the capacitor is how much? 24, 24, 1 minus e to the power minus 3 by 20 microcoulomb. Okay, this is the answer, Kirtana. And if you want to try, you can try. I won't give the solution today for this one. Take it as your homework, and we'll give the solution for the next class. Is it clear?
Okay, sir.
Okay, any difficulty Kirtana you have in this chapter till date? Any kind of difficulty, anything confusion you wanted to ask and have query over that? Anything, any problem with in this chapter? Hello, Kirtana, are you there? Yeah, Kirtana, I'm asking something.
No,
Any doubt? No doubt, right? Okay, Kirtana, look, take it as your homework problem, and I want solution for this one in the next class. Okay? So, yeah, you can do this. All right, Kirtana, I'm ending the session by this. Good luck. Okay. I will share the solution and this thing also. Not solution. I want to share the solution. You will get the sheet. Okay? Goodbye, Kirtana.